This video we're going to be talking about triangle similarity and more importantly, proving them similar. Right? What does it mean to prove that two triangles are similar? Keep in mind what similar means. If two shapes are similar, then they have the same shape, but they are different size. Okay, let's get into it. This will be the first of three ways to prove triangles similar. This will be the angle-angle similarity. Notice the similarity tilde right there. We need to make sure we include that in our statements. So this will be angle-angle similarity. If two corresponding angles, right, are congruent, then the triangles themselves are similar. So if you take a look in your notes, you'll see the statement right below that angle-angle similarity statement. It says, determine if the angles, right, you're going to make a determination, a decision, if they are similar by angle-angle. So first, we take a look. I see that I have a 75-degree angle here and a 75-degree angle here. But the other two angles don't match. What we need is to determine the third angles in both triangles. So first we are going to determine, right? We're going to determine the third angle value for both of the triangles. So that's going to require a little bit of addition and subtraction. So after a little bit of legwork down here, I subtracted my 74 and 75-degree angle to get the third angle right here is 31 degrees. And then right here, I've determined that the third angle on the second triangle is 74 degrees. So the question is, do I have two angles that are congruent? Yes. I have angle B. Angle B is congruent to angle E. And I have angle A is congruent to angle D. So are these two triangles congruent by angle-angle? Yes. So my final answer is going to be a yes, and then I'm going to state triangle ABC is similar to triangle DEF by angle-angle similarity. So that's my final statement, and the math we showed that the angles were similar. Okay, so now we're going to move on to number two. Just a little note that we've left our final answer here, and we're going to bring number two to the table and see what's going on. Now, we don't have any values here, but we have been given that angle V is congruent to angle Y. Are there any other angles that are congruent? Absolutely. By vertical angles theorem, we know that the angles formed at vertex X are congruent by the vertical angles theorem. So we have two angles. So by angle-angle similarity, yes, these two triangles are congruent. So let's name them. So let's call the first triangle, triangle XVW is similar to, and now we got to get this order correct. So X is going to be the same angle, right? Corresponds to itself. And if we went from X, the double mark, to the single, and then from the single to the unmarked, then that means we're going to go from X to the single and from the single to the unmarked. Same order, so that's going to be X, Y, Z, right? They are similar by angle-angle similarity, and that's that. Okay, so now on to our second out of three ways we can prove triangles are similar is by side-side-side. Now, don't confuse side-side-side similarity is not the same as side-side-side congruency, right? This was for proving triangles congruent. So it's important that you include the similarity symbol because that's what distinguishes side-side-side congruency from side-side-side similarity. All right, so if all, I would circle this, right? All corresponding sides are proportional, then the triangles are similar. So what does that look like in practice? Determine, right, make a decision if the examples below are similar by side-side-side. If yes, write a similarity statement. So if no, then just write no. But if yes, let's write a statement. So first, let's go around and name all the sides from this triangle. So we have 3, and then we have 4, and then we have 5. And that was from least to greatest side length, okay? I put them in order. Now, if they are proportional, it must go from least to greatest on this larger triangle. So 3 would correspond to 6, 4 would correspond to 8, and 5 would correspond to 10. So the question is, are these in proportion to each other? So what is 3 divided by 6? That's 0.5. That should equal 4 divided by 8, which is also 0.5. And 5 divided by 10 is equal to 0.5. That's all the same. So are these all in proportion to each other? Yes. So we're going to say that yes, these triangles are similar. So we got to get a triangle similarity statement. So yes, triangle. And again, I'm just going to start with P. P, Q, R is similar to triangle. And if I started with P, that's between the 3 and the 4. I think that's the same as starting with S going to T along the medium side. And then I started P, went up that short side, S up the short side, down to U. By side, 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 similarity. Okay, so let's try that again. We are going to list the 3 sides from least to greatest. Okay, so the smallest side I see here is 30, so I'm going to say 30. The next size bigger is 32, and the largest side is 35. If these are in proportion to each other, then the smallest will be in proportion to the smallest. Onward to the middle side, that's 25. On to the largest side, 28. And I'm just going to simply do the division and see what I get. So what is 30 divided by 24? And I get that 30 divided by 24 is 1.25. And then I check 32 divided by 25, and I get 1.28. Those aren't the same, so right away I could just stop right there and say no. Right? I've determined that they are not similar by side, 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 so no need to go any further. Now, one of the questions probably is, well, what happens if I had written it the other way? What if I wrote 24, 25, and 28 over 30, 32, and 35? It doesn't matter, right? Because 24 divided by 30 is 0.8. 25 divided by 32 is 0.78125, so no. So either way, it's a no, no, no. All 3 must be equal. Otherwise, we're out. This is about comparing ratios. Lastly, the third out of 3 ways to prove that triangles are similar is side angle side. Again, side angle side similarity is not side angle side congruency, so be careful not to forget that similarity tilde. All right, so how do we prove that triangles are similar using side angle side? The same as we used to prove triangles are similar. We're going to have 2 corresponding sides that are proportional, and the included, right? That's important. The angle that's between them are congruent. All right, let's see how it works in practice. First and foremost, we're going to determine, right, if the examples are similar by side angle side similarity. If yes, we'll write a statement. If no, we just write no. So 8 is the smaller side. Who's the smaller side over here? 6. So 8 is to 6 as 20 is to 15. Now, should we even bother checking to see if these are similar? Just make sure that the angles that are marked congruent are the included angle. So yes, this is the included angle here. And yes, this is the included angle there between the 2 sides given. So now we want to check to see if these are in proportion. So you could either do the division or you could check their cross multiples. Well, let's do it both ways. First, let's check the multiples. Is 8 times 15 equal to 6 times 20? And yes, that's true. So we're going to say yes by side angle side similarity. triangle JKL is similar to triangle. If we started at J and went down the short side towards there, we're going to start at M and go towards the short side towards N. So that's going to be M, N, P. Now the other thing we could have done is I could have also just done the division to check to see if they're in proportion to each other. And 8 divided by 6 is 1.3 repeating. 20 divided by 15 is 1.3 repeating. You could have written it as 6 over 8 and 15 over 20. You check it that way. 6 divided by 8 is 0.75. 15 divided by 20 is 0.75, and that equals, right? So either way, yes, 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 and yes, right? This one works. Number 5 works. Onward and upward to number 6. So I see that this side here is worth 12, and this side over here is worth 15. And the big side here is worth 25, and the big side down here is worth 21. Obviously, these two triangles share a common angle here. That is the included angle. It's going to be congruent to itself, so it's worth investigating if they are in proportion. So I'm going to take the small side, 12, compare that to the larger side it shares, 21. Come over to the other side, the 15 length side on the small triangle compared to the 25 length. Now we're going to turn around and see if this works out. Now we can reduce the fractions to see how that works. So 12 over 21, both divisible by 3. Both divisible by 3. So that's going to give us 4/7. And 15 over 25, these are both divisible by 5. And I'm going to get 3/5. And those are not the same. So the answer to this is no. Again, what are some other options? Okay, other options are, I could have checked their cross multiples. 12 times 25 should be equal to 21 times 15, if that's the truth. Okay, are these in proportion? No. So again, the answer is still no. And then 12 divided by 21 would have been 0.5714 something. And 15 divided by 25 would have been 0.6, and that's not right. So again, still no, they're not in proportion. So no, they are not similar by side angle side. Okay, so now we're ready to do a little bit more practice. First, we're going to focus on just angle similarity. So again, we need two angles to be congruent, and then that's enough. So what do I notice? I see that this and this are parallel, which means that this is a transversal, which makes this angle congruent to this angle. I also have the vertical angles. So do I have two angles congruent, or two angles that are congruent? Yes. Is that enough to prove these are congruent triangles? Yes. By angle similarity, I can say triangle DCE. Now, if I start on the angle that I didn't talk about on this triangle, then I'm going to say that that's similar to the angle I didn't talk about on this triangle. As I move from D to C, the single arc, I'm going to move from F to G, the single arc, and come back to E. Right? E corresponds to itself, so that's good. By angle similarity. So here's our sort of final answer. Moving on to number 2. Number 2, I have a big triangle here, and then I have a small triangle here. Now obviously they share the same angle up at angle L, so angle L is going to be congruent to itself. I have some parallel lines right here, making this a transversal, which means that these angles are congruent to themselves. So let me clean this up a little bit so we can see what's going on. What we've said is L is congruent to itself, and then the angle here at Q is congruent to the angle at M. Also, we know that these two angles are also corresponding angles, but we only needed two pairs. So we have enough to say that yes, by angle similarity, triangle, and I'm just going to name the smaller triangle in no particular order, QLP, is similar to, now if I started at Q, I got to start at the angle that's congruent to Q, which is angle M. And if I went from Q to L, then I'm going to go from M to L. So MLN. And there's my final answer here, number 3. There's no parallel lines or anything, but I do notice that this is a 90-degree angle. And I also notice that right here is also a 90-degree angle. Now again, I have to find the third angle's value. So I'm going to subtract 90 and 39 from here, and I'm going to subtract 90 and 51 from here to see if I have identical values. And lo and behold, after I do the math, I have 39 and 51 respectively. The 51 here is over here at S, which matches up with W. Obviously, I have the 90-degree angles that match up, and I also have the 39-degree matches up. So by angle similarity, yes, triangle, and again, just in no particular order, I'm going to say SYE down here is similar to who? If I start at S, that's the 51, I got to start with W. If I go to Y, the 90, I'm going to go to C, the 90, and H is my last one. So that was a yes. Moving on to number 4. Number 4, I have 68 and 54, and over here I have 63 and 68. So I have 68 and 68. Let's go find these third angles. Find B and E. Right? Press pause and calculate those values. Do this on your own. Try not to have me doing all the work again. If you don't do the work, this won't make sense to you. You should be agreeing with my work, not copying my work. And so what do we notice? We notice that 58, 49, 63, and 54, I don't see any other angles. The only two that match up are the 68 and the 68. So this is no. And that's it. We move on. No similarity statement because they're not similar. You complete 5 and 6. Okay? Press pause and complete 5 and 6. One of them is a yes and one of them is a no. See me for help if you need it. Now a little bit more help with side-side-side similarity. Again, these are really easy. Just list the sides in order. Again, as I said, list the sides in order and check for all 3 sets. All 3 sets to be in proportion with each other. If so, then yes. If not, then stop. So I look at the smaller triangle and I list the sides in order. It's 9, 13.5, and 27. In order over here looks like 14, 21, 42. Now just check to see if all 3 sides have the same ratio. So first, 9 divided by 14. And again, it doesn't matter who goes on top as long as you are consistent. And it looks like, as I do all of the division, everything works out to be 0.6428 and then some, but all the same exact answers. So the answer here then is yes, by side, side, side similarity, triangle on the left, I'm just going to name it KNR, is similar to, on the right, if I go from K to N down the smallest side, and then I'm going to go down the medium side, and I'm going to go from D to E down the smallest side, and then along the medium side, that's going to be DES. Okay, so order matters here. So, onward to number 2, or rather, number 8, the second one in this section. I have a small triangle here, and I have a large triangle here. So first and foremost, I need to get the side length of the large side, which is 20 plus 8, which is 28. So that's the length of this whole side. Then the length of the whole side over here is going to be 15 plus 6, which is 21. So let's neaten this up a bit. Now let's talk about the lengths of the smaller triangle and size 15 onward to 20 onward to 40. And I'm going to compare that to the lengths of the larger triangle, which go from 21 is the smallest, 28 is the middle size, and 56 is the largest. Now I just want to check and see if this statement is in fact true. So we take 15 and then we divide it by 21 and we get 0.714. And I compare that to 20 divided by 28 and that's 0.714. And 40 divided by 56 and that's going to be equal to 0.714. So it looks like this is a yes by side, side, side similarity triangle. And now we're going to name the smaller one. So let's start at X and go towards W and down to V is similar to, if we started with X, then we're going to start with Y and head down that same road, Y, W to U. Now, up at the top, it should be noted that 15 and 21 are both divisible by 3, so that's 5/7. 20 and 28 are both divisible by 4, which leaves us with 5/7. And 40 and 56 are both divisible by 8, which leaves us with, guess what, 5/7. And of course, if you know how to reduce your fractions, those are all equal and we're in good shape, right? Still reveals us the same thing, that they are in proportion. And then I would still say this same answer. So there's a lot of ways to show how they are in proportion. Okay, we'll go into a number 9. Now list our sides in order. So 5, 12, 16, compared to in order 3, 7, and 10. And the question is, do all of these reduce down to 5/3? If I reduce 16 over 10, those are both divisible by 2, I'm going to get 8 over 5, which is not the same as 5 over 3. And this doesn't reduce, so these are not the same. So this answer is already a no. But let's approach it from the sort of division aspect, or looking at these ratios with decimals. Okay, as I roll down, right, 5 divided by 3 is 1.6 repeating, 12 divided by 7 is 0.1714, so that's no. We could stop right there, and just for the record, 16 divided by 10 is 1.6 exactly, which is not any of those. So none of those are the same, so no. And I think that's about enough there. You can finish 10, 11, 12 on your own. Okay, again, press pause, right? Complete 10 through 12 on your own. You're going to have 2 yeses and 1 no. Then come back to the practice. So our last practice here, we're going to work with side-angle-side similarity. Remember that we need that included angle between the 2 sides. So number 13, I see that I have vertical angles. They're not marked congruent, but I know that they are. And that is the included side between these 2. So I'm going to start with the triangle on the bottom, and I'm going to list the 2 sides, 6 and 12, from smallest to greatest, and see if that's in proportion to the other 2 sides on the triangle on the top. And from smallest to largest, they are 24 and 48 respectively. So let's see what's going on. Up in this top fraction, 6 over 24, 6 goes into both of those. 6 goes into itself once, and 6 goes into 24 4 times. For 12, 12 goes into itself once, and 12 goes into 48 4 times. So we are in proportion. So yes, by side angle side similarity. Triangle, and I'll just say the one on the bottom. I'm going to start with E. I'm going to go down the shortest side to R and over to S is similar to. I'm going to start at E again because that's the corresponding angle, going down the shortest side towards F and finishing up with G. That is my final statement, and order matters in this. Just for the record, if you had gone the decimal version, this would have been 0.25 and this would have been 0.25, and that would have worked out, and we would have said yes, just the same. On number 14, we take a look and we have our vertical angles here, no other angles given. Now the question is, are they the included angle? And so what do I notice? I notice that I'm given this side here and this side here. That would make that the included angle. I'm given this side here and this side here, which would make Y the included angle. So since the vertical angles aren't the included angles, we're just going to stop right there and say a big fat no. All right. Onward and upward over to 15. I see that I have a pair of parallel sides and a transversal, making these corresponding angles. And they are the included angles for the given sides. So that's great. Since they are the included angle, it's worth comparing the sides. So I'm going to start with the triangle on the left and then work to the triangle on the right. Triangle on the left, I have 36 and 54. And I'm writing that from least to greatest. Triangle on the right, I have 22 to 33. And I'm just going to compare these two ratios. And I'm going to do some division. So 36 divided by 22 is 1.636 and some change. And 54 divided by 33 is that same 1.636 and change. So they are in proportion. So we're going to say yes by side angle side similarity. And I'm just going to name the triangle on the left. I'm going to start with C and work my way up that way. So CMP is similar to. And since I know my angle M matches up with P, I'm going to start with R and work my way up that way. So that's going to be RPQ. And we're in good shape. Again, notice I know that M and P are congruent, and M and P are both the second letters in my statements. So I know that this is a pretty solid statement. When I look at number 16, I see that I've been given that the included angles are congruent, and they are the included angles between the two sides. So I'm going to let you work out the proportional statement, okay? Again, press pause and work on this on your own, 16 through 18 on your own. You should arrive at 2 yes answers and 1 no. As you move on to the mixed practice, right, now you have to decide, is it angle-angle similarity, side-side-side similarity, or side-angle-side similarity on your own. So now this is all mixed practice, and you're going to go from 1 all the way to 18 on your own. So 1 through 18 on your own, and I'll just guide you on a couple of random ones. First, I'll help you sort of go in the right direction. On number 1 here, I notice that I'm given 2 sides and an angle, 2 sides and an angle. So it looks like this might be side-angle-side similarity. Versus number 2, it looks like I've been given 3 sides and no angles. So maybe this is side-side-side similarity. Down on number 4, again, looks like 3 sides. So this looks like side-side-side similarity. Okay, question mark. Over on number 3, I'm just given all information about angles, no sides. So is this angle-angle similarity? That's what we have to kind of decide first, is which one are we pursuing? Back to number 1, is this the included angle? Yes. Is this the included angle? Yes. So 3 and 5, and then 9 and 15. And I think the fastest way to compare these is to reduce the fractions themselves, or the ratios. So this is going to be 1/3, and this is going to be 1/3. So those are definitely in proportion. So yes, blah, 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 by side angle side. And then you're going to have to get some triangle similarity statement. So by side angle side similarity, triangle blah, blah, blah is similar to triangle blah, blah, blah. So you have to finish that statement. On number 2, again, looks like side, side, side. So in order of least to greatest, 22, 28, 35. And then from order of least to greatest on the other one, looks like we got 16, 20, 25. And let's see if those work out. If so, then yes. If not, then stop and say no. For me, I think I would go with reducing these fractions. And so then if no, stop. If yes, write a similarity statement. On number 3, looks like angle-angle similarity. Find this value, find that value, and then make a decision. On number 4, let's take a look. The length of this whole side, right, that's the key, is going to be 20. The length of this whole side is going to be 18 plus 6, right? That's going to be 24. And the length of this whole side has been given, the length of this whole side has been given. So compare the big triangle to the little triangle, right? The little triangle is going to be 12, 15, and 18. Compared to the big one is going to be 16, 20, 24. Decide if that's true. If yes, then write a statement. If no, then just write no. Just a heads up, on numbers 1 through 4, you're going to have 3 yeses and 1 no. How about the next section? It looks like we have a set of parallel lines and a transversal. So we have corresponding angles here. And then we have another set of parallel lines and that same transversal. So I think that we'll have these angles congruent. So it looks like we got a couple of angles here. So I think we're already ready to say yes. Angle similarity for number 5. You just got to get your triangle similarity statement worked out. So that's kind of done for you. Over on number 6, it looks like I have some side lengths here. So keep in mind that the whole length here is going to be 44. Right? We have a small triangle and a big triangle that we want to compare. So this whole length here is going to be 65, and they both share angle D, so that's going to be that common included angle, and it is included between the two sides on both. So it looks like this is a side-angle-side similarity. So see if you can set up the proper ratio, check and see what's going on, and make a decision. For number 7, again, you have 2 angles here and 2 angles here. Check to see if these two match up, and you might have an angle-angle similarity. Down here, looks like we have vertical angles that are congruent. It looks like they are the included angles, so perhaps side-angle-side similarity. Check that out. And just a little word to the wise. For numbers 5 through 8, you're going to have 2 yeses and 2 nos. For numbers 9 through 12, there are 3 that are a yes and 1 no. 13 through 16, 3 yeses, 1 no. 17 and 18 should both be a yes. That's a horrible arrow. And they should both work out, but make sure you have the work to support that conclusion. Okay? And that'll do it. Good luck. I know this is a lot to swallow down, but really watch your order and make sure you're consistent about your proportions. Okay, so again, watch the order. Be consistent in your proportional statements. See me for help. And most of all, don't quit. Okay? What is mathematics supposed to help? Mathematics, especially proving triangles similar, will develop your perseverance in problem solving, right? This is awesome. It is difficult. We know this. But this will make your brain stronger, and that's great. Okay? Hope that this will help, and I'll stop tripping over my words and let you get to work. Good luck.